All right, so this video today is going to help you do some of the application problems in today's homework. In our Blitzer book, they have a sort of unique take on using bearings to describe motion. And normally bearings come from north, but they will do it a little differently. So we're going to talk about what does this notation mean and how do we set up our problem using their bearings. So in our book, it will say this notation right here, n 50 degrees east. And what that means is that whatever object is there or is moving or you're located at an angle 50 degrees east of north. So if you imagine, you have the compass rose, sort of looks like this, where this is north, south, east, west. So a 50-degree east of north means I'd start up here at the north and I would go 50 degrees this way. And so this angle right down here would be 50 degrees. And that would be an angle that's 50 degrees east of north. All right, we could try something sort of similar. They might have something like this where it's south 50 east. And see if you can guess what this would mean. And what it means is we would have an angle 50 degrees east, oops, of south, of heading due south. So again, here's due south, and we would go 50 degrees to the east of that. So this would be our angle right there. Would be a 50-degree angle from due south. Okay, so let's put it together in one of these sample problems. So I want you to pause the video, read this, and see if you can draw a picture. So hopefully you're back. And the picture that we have should look sort of like this. I mean, you might not have put everything in the same place, but what we have right here is we have two fire stations, A and B, right there. There's a fire to the north, so from where they are, this is to the north of that location. There's our fire right up there. The bearing from A to the fire is 50 degrees east of north. So here is the due north, and we go 50 degrees east of it. So there's our 50. The bearing from station B is 36 degrees west of north. So again, here's north from there, and we went 36 degrees to the west side of that. And then the other thing we know is that they are 20 miles apart. So this right here, 20 miles. And now we have a picture, but I need the angles to make up this triangle because I want to know how far to the nearest tenth of a mile is the fire from station A. So to answer this question right here, what do I need to find? The distance from A to the fire. In other words, I need side B. So I want you to pause again and think about how can we find that missing piece of this triangle. So hopefully you went through the process of, can I do law of sines? And while it might not have seemed so at first, because I don't have a pair of angle and side opposite, I have this angle, but I don't have side A, I have this angle, and I don't have side B. But if you think carefully, if I have two angles in my triangle, I know my third angle. The third angle is 180 minus 40 plus 54, and that leaves 86 degrees for this angle. And now I do have a pair of angle and side opposite. And so I can set up my equation, which says that the sine of 86 degrees divided by 20 has to equal the sine of angle B, which is 54 degrees, divided by B. I want to solve for B. Oops, we are getting smaller and smaller. And so I want to multiply both sides by B, or your cross multiply and divide, however you think of it, because this would get rid of that. And if I multiply a 20 here and a 20 there, and I get, for my answer, I get 20 sine of 54 degrees divided by sine of 86 degrees is b. And if you estimate that, you get approximately 16.22, and that would be in miles.